Hello friends, welcome back. Welcome to the new episode of Concepts of CISSP. In this video, I will be doing a recap of what I have shared in my last video and will be sharing with you my notes on the screen. As you can see here, it will be scrolling as I am speaking. So cryptography is a branch of cryptology, and cryptology is defined as the art and science of doing encryption and decryption, encoding and decoding of the message. So there are broad two categories of cryptology. One is cryptography, another is cryptanalysis. So cryptography is a systematic process. It's a well structured process where you take a plain text message, which is the message we refer as plain text message, and we modify this message in a way that no one can read it except the person who knows how the message is modified. This information that how a message is modified is called the key, right? So actually you have a message and you apply a key, and with application of the key the message is transformed into another type of message, which is an encrypted message. And the only way you can find the plain message from encrypted message is applying the key again. As you can see in the field of cryptography, you encrypt a message and you decrypt a message. It's a normal process. Message, key, then you encrypt it. An encrypted message, you apply the same key, you get the decrypted message, which is cryptography. Cryptanalysis is a different area where you try to find the plain text from a given ciphertext or encrypted message. Sorry, I was missing this word ciphertext. So ciphertext is also a name for the encrypted message, right? So you have got a ciphertext and you apply some logic, some reasoning, some guesswork, and you try to decode the plain message. That is cryptanalysis. So there is a very sharp difference, very defined line between what is decryption and what is cryptanalysis. In decryption it is assumed and it is known that the person who is doing decryption or the machine who is doing decryption is having the key, right? Cryptanalysis is another area where you don't have the key. You apply some parallel methods to come up with what is the plain text. So this is how you should see cryptography and cryptanalysis, which is both part of the broader term, which is cryptology. Now as you can see in the diagram, you have got a plain text, you have got a cryptographic system. You feed the plain text into the cryptographic system and you get what is called the ciphertext or unreadable message, unreadable text, which is also called an encrypted message. So in cryptographic system you have got an algorithm and you have got a key. So cryptographic system is a piece of hardware or software which takes plain text as an input and a key as an input, and it generates something which is called encrypted message or ciphertext or unreadable message, right? Whereas in cryptanalysis, what you do is you take the ciphertext or the encrypted text, and without applying the key, because the key is not available to you, you do some guesswork, you do some trial and error work, and you come up with the plain text. This is what is meant by cryptography and cryptanalysis. Now, moving next, what we do in the field of cryptography is you essentially transforms a message from plain text to ciphertext, right? So there are two methods of doing that. Either you do substitution method or you do the transposition technique. So in substitution method, what you do, you just substitute or you replace the character. So if you write something like your name, like I am Rashid Siddiqui, then what you do, you change I with some other character, A with some other character, but there should be some logic to it so that the person who is receiving the message can decrypt it. That is substitution method or substitution technique. In transposition technique, not only you just replace, you do some permutation, you do some mathematical operation, AND operation, XOR operation, you do some you can do some arithmetic operation as well on numbers like multiplication, division, or you can do complement, transposition. So all those things you apply in addition to the substitution. So then it is called the transposition technique. Transposition technique is more effective than substitution technique. As you can think, it's quite logical that when you apply more randomness to a system, it becomes more unpredictable. So that's what is substitution technique and transposition technique. If you apply both the techniques all together, it is called product cipher. So you're doing substitution plus you are doing transposition, then it's called a product cipher. Now, some well-known substitution techniques are Caesar cipher, monoalphabetic cipher, homophonic cipher, polygram cipher, polyalphabetic cipher, which is also called Wegener cipher, Playfair cipher, and Hill cipher. In CISSP exam, no one is going to ask, there will be no question on like the detailed mechanics of how these ciphers actually work. But if you are interested, if you feel curious, you can go back in your regular cryptography books and you can read about it. There are some reference into the official CISSP book as well, which can be referred. So these are the key substitution technique. When it comes to transposition technique, rail fence technique, simple columnar transposition, Venom cipher, which is also called one-time pad, book cipher, which is running key cipher. So these are the transposition technique, right? So this is how the progression of discourse happens in cryptography. First, you should know that there is something called cryptology. Then you have got cryptography and cryptanalysis, and then there are two type of techniques: substitution technique and transposition technique, in order to change a plain text into ciphertext. Now, I briefly reference something called key, right? So in encryption, in cryptography, either encryption or decryption, you have got a plain text, then you have got a cryptographic system, and then you get a ciphertext. So the cryptographic system itself has got two things. One is algorithm, other is key. Now, algorithm is known to everyone. Everyone knows what is cryptographic algorithm, right? All the cryptographic algorithm which we will be studying in CISSP is a public documentation. Anyone can read about it. Everyone knows, even the attacker knows, sender knows, receiver knows, the whole world knows what is the cryptographic algorithm, right? Now, the thing which is secret is the key with which we encrypt the message, and the length of key is the degree of complexity. So a small key length, easy to do cryptanalysis. If you have large key length, it's more difficult to do the cryptanalysis. Eventually, any message can be decoded, but the key thing is how much time it takes. Like if it takes an hour to decrypt, it's easy, no one will use it. If it takes like 50 years to decrypt a message, then I think that's a pretty strong encryption. So that's how the relation is. You can think of the size of the key is directly proportional to the complexity of the encrypted message, or complexity to do the cryptanalysis on a given ciphertext, right? This is one more point you should have in mind for CISSP exam. This type of question can be phrased in CISSP questions. Now, this key is very important. The key is something which is of prime importance in a way that it defines the type of encryption we use in our software or hardware. So depending on the type of key, we have got two type of encryption technique. One is called symmetric encryption technique, another is called asymmetric encryption technique. So in symmetric encryption technique, you have got only one key, which is used to encrypt the message and the same key is used to decrypt the message. And in asymmetric technique, you have got two keys. One key is to encrypt the message and another key is to decrypt the message. It is very important for us to understand the mechanics here, like how symmetric key works and how asymmetric key works. It's not that important to understand how the substitution technique, different substitution techniques works, how different transposition techniques works. If you are interested, you can go back and read. But when it comes to the encryption techniques like symmetric encryption technique and asymmetric encryption technique, you should really know the concept behind it, right? So I will be explaining those concepts behind it, like what is meant by the two keys in asymmetric key and how it is used to achieve different information security objectives. Now, in symmetric key cryptography or symmetric key algorithm, there are two key aspects of the algorithm, right? So we are jumping on now symmetric key. Now, before I explain to you the properties of the key, this piece is also important, so I am just explaining it. You can have this in your mind. It will give you a sort of confidence in knowing the boundary in which we are playing this subject, right? So you have got algorithm type and then you have got algorithm mode. So there are two key categories here. So when it comes to symmetric key cryptography or symmetric algorithm, you define symmetric algorithm with algorithm type and algorithm mode. Now, algorithm type defines what size of plain text you should be encrypted in each step. So in symmetric key encryption, you will be having different steps. In each step, what is the size of key that will be given, that will be defined by or characterized by the algorithm type, which is also called the input size, right? Input size of the symmetric key algorithm. Now, this algorithm type could be either a stream cipher or block cipher. Now, a stream cipher is a type of algorithm, is a type of symmetric key algorithm or symmetric encryption technique where you do encryption bit by bit, one bit at a time, right? So, and it relies only on confusion, which is substitution technique. So, in symmetric key algorithm type, which is a stream cipher. So, a stream cipher is a type of symmetric key algorithm. Now, this cipher, a stream cipher, is actually encrypting the message in a way that it encrypts one bit at a time. So, if you are doing one bit at a time, the only thing you can do is substitution. So, this is an important exam sensitive point you should keep in mind, that a stream cipher encrypts one bit at a time and it uses only substitution technique. Can it use transposition technique? No, it can't, because in transposition technique you do some mathematical or logical operation on a set of bits, right? But if you are doing one bit at a time, you can't take a set of bit. So it's kind of contradictory, right? So the important point about a stream cipher to know is that you encrypt bit by bit, one bit at a time, and you use substitution technique only. Whereas in block cipher, you take a block of bits at a time, so, and it relies both on confusion and diffusion, right? So what you do in confusion, you do substitution. In diffusion, you do transposition, and you basically do both substitution plus transposition technique on a block of bits. That's called block cipher. Now we define block cipher for algorithm mode only, which I'm going to explain next. What is algorithm mode? So algorithm mode is a combination of a series of the basic algorithm steps on a block cipher. You don't define algorithm mode for a stream cipher. This is also an exam sensitive key point you should keep in mind, that we define algorithm mode only on the block ciphers. You don't define algorithm mode for stream ciphers, right? Now there are the instances where you treat a block as a stream. that is a different case which I will be pointing out in upcoming videos, or I have already made a video actually, which I will be putting a link in this video. You can just click I button and go to that video. In that video you will see different algorithm mode, which one is treated as a stream, which one is treated as a block. So in a stream you will notice that it's not the classical stream like bit by bit, but the block is treated as a stream. It's like understanding the mechanics of the encryption algorithm. Now these are the basic information you should have in mind. You should know what is cryptology, you should know what is cryptography, what is cryptanalysis. You should know how we transform a plain text into ciphertext with different techniques, substitution technique and transposition technique. You should know that depending on the type of key, we have two type of encryption available. One is symmetric key encryption, one other is asymmetric key encryption. In symmetric key encryption, we define algorithm type, which signifies the size of the key, which is also called the input size. And then we have something called algorithm mode, which is the detailed mechanics of how encryption steps are being performed, right? And algorithm type is a stream cipher or block cipher. Stream cipher is only encryption bit by bit, one bit at a time. It works only on substitution, whereas in block cipher you do substitution plus transposition, right? And there are different algorithm modes like electronic code book, cipher block chaining, cipher feedback, output feedback, counter, CCM, GCM, and I'm not going to explain that again. As I said, this is already explained in my previous videos, and the link to that video will be here on the I button, so you can refer it. Now, with all this information, the next thing we should understand is what is the key, like in symmetric key, and what is the key in asymmetric key. I think if I'm going to explain in this video is going to be too long. So our next topic will be understanding what is the nature of key in symmetric encryption and how this key is exchanged between two participants, right? So if you are exchanging key between two person A and B, then there is a chance of this key being hacked as well, and the chance is no less or greater than the chance of getting message hacked, right? So how we ensure the safety of key, which is crucial to encrypt the message. So stay tuned, we will be discussing that part in our next video, and then we will be jumping on asymmetric key encryption. Thanks for watching the video. If you like this video, put a thumbs up. You can share this video with your fellow friends who are preparing for CISSP, and please don't forget to subscribe the channel. Thank you.